Well, last year I saw this presentation by Nima Safwati or Nema Safwati. I apologize if I'm pronouncing it wrong. Lines and basically threads overlaid on top of the geometry cloth that is having a different tear solver. And I was inspired by this effect and a few more effects that I saw of this uh, thread basically tear effect, which in this one by Linus Rosenquist, if I'm pronouncing it right.
Fractured.
Yeah, yeah, you could see these threads. These are quite beautiful. So it's been a while that I want to do some similar effect. Alright, we're in Houdini and we can start building our procedural system. Like always, we start with the geo node and create a sphere. And just put this on smooth shaded. Disable the grid for now. And we're going to scatter some points on this sphere. And it would be nice to have a procedural group for the purpose of this video. For now, I will do a rudimentary selection. So, yep, let's go for half of it. Nice. And we duplicate this. This time we push Control I to Houdini. Yeah, Control I, Enter. Yep, that's working. So we have scattered points on both halves. It's just they're very uniformly distributed. We can even disable the relax iterations for now. And we will jitter them, so there is a little bit of jitteriness to them. And we can bring it up. And we can duplicate the same here. Change speed. So we have a different point jitter. Because by changing the seed, we basically change the random order of jitteriness on these points. So now we can start by connecting these points as lines, and we can do that through a point triangle. This connected as the first input, this one as the second input, so 0 and 1. So to create a line between these two geostreams, these two sets of points, we can do it this way by defining a vector. Let's call it position. I'm gonna read the point attribute, the position attribute of the geostream 1. Let's assign Butinum for each number. point, 0 position, the red position basically, and div. Yeah. Well, let's see what we did. Oh yeah, we had to also specify our first point integer. So first point. Oh yeah, and polyline is not capital. I apologize. So as you can see, it is quite ordered. So you might want this orderliness, but I rather if it was a bit more chaotic, so more random. So one thing I can do is I can change the sorting of the points randomly, at least one view stream. And this way you can see lines are just going into each other. And so we can continue from this point forward. So what we are going to do, we want to basically run a Vellum solver in this and simulate these as hairs and basically start pulling them from top and bottom to get the stretch. And for that we need to do some preparations. So first we need to resample this and use also the connectivity node to basically separate the hair strands based on their connectivity attribute. It is also quite funny that I did this with changing the sorting because you really don't have to do that. I just wanted to demonstrate what the order of the points actually means. And basically these points are, if you can see, very similarly distributed. And so in order to have them randomly connected, we need to at least change the order on one side. So in order to do that, we really don't need this sort node. We can do that by, first of all, let's just disable the relax. And yeah, we can do that by just changing the seed on one of the scatter nodes from the other. So then they have a different distributed set of points. That way the order will be random. So let's get to the rest of this. I'll do Shift L to lay out my nodes. And yeah, let's start resampling. We can see the points better this way. Let's go to 0.02 and let's even do a mountain node on it. So we have them a little bit noisy. Let's decrease the element size. Let's decrease the amplitude. Let's put it on, yeah, 0 centered is good. We can even try different noise as well. Yeah, maybe worldly. Or you can play with this forever. Alright, let's add a connectivity node. Let's add a connectivity node. Yep, that's it. Separate them by basically different classes. And let's increase the number of points on both sides to 10,000. Well, 10,000 may be a little bit of overkill. Uh, let's go with 5. Yeah, I don't want to use my PC to this tutorial. So, yeah, let's make a top group where we basically select the points top. Let's do bigger than the actual boundaries of our sphere. Let's do this. Yeah. Let's call this top group. Let's go make another one. Do the same. Call it bot group. And we can even copy this. Put it in size. And then bring this lower until the section we want. So this will be our 2 sections separated now. And now we can do 2 transforms, and one will be on top group and it will be on 0 with alt click. We will create a keyframe on the 0 position, and then let's say after 120 frames, or let's say after 100 frames, and let's limit our sim to 150. Let's do 130 and move it 2 points into the y direction. 2 units, sorry. 2 units is good, or maybe 1.7. Yep. And then with shift click you can, with space edge and F as well, you can frame your curve, and then Control A to select both points and then straighten them to make them linear, so the motion is linear. We duplicate it. Now for the pot group, and we make it -17, shift click, space edge, F to frame, Control A and linear. Yep. So now we have two ugly animations of our separation. So now we have to simulate this. But before animating them, I'm gonna add a convert line node here to just make sure that our lines are really separated by on primitive basis with the rest-length attribute calculated. So I'm gonna continue by adding thresholds and when the breaking happens exactly, so we can randomize that, and we have different breakpoints at different stress points basically. To do that, we will create an attribute randomizer, and attribute name, we will call it B break scale, and we're gonna have it on uniform, and let's now add a noise attribute with noise, and let's call it break scale 2, and yeah, so we have created break scale, and now we're gonna create a new one, break scale 2, with an attribute noise, and we can remap this and basically have a different noise. You can even visualize this so you can see what exactly happening to these values. You can even read them here. So this is break scale, this is break scale 2, which are the 3 values for break scale 2 and 3 values because this is a vector. Yeah, for each point. With each position, you can read it here now. And with that in mind, we can make the amplitude a little bit different on each part. So there is some emphasis on differences of break scale attribute that we just made. Now we connect this to a Vellum Hair configure, and that way the hair constraints are automatically set up. So now we can remove the visualization so we don't have any issue here. And yeah, it's already set on calculate varying. We can visualize the thickness here and see that we need to basically change our thickness to something that is more fitting to the thickness of the hair. Yeah, this makes more sense. Maybe a little bit more thicker. Perhaps I think it's good enough. Let's disable visualize thickness so it doesn't process this much. Define pieces from connectivity. This is why we had the connectivity node, and now we added the top and bottom group match animation because they are animated, and now we can set the scale for stiffness of stretch and stiffness in bend. Basically, this is okay, and this is the breaking threshold. And we can put this on scale by attribute, and we call it break scale 2. Put stretch, sorry, the breaking threshold or on something below 0.1, and so sorry, we put this on break scale not 2, the first attribute randomizer we created. Yep, this is it, little glue. And this is actually why we used the connectivity node. So here we can connect the close points of each thread to each other, and we can set this to 0.8, maximum search points 45, let's say. This something like 0.02 detach point chance, which is each pair of points has this chance to be being marked ineligible for gluing. So each pair of points, half of them have the chance to be detached, and this one also is a chance of creating little pieces, so stray hairs basically. And constraint per point, so I'll put it to 3, search preference nearest, and yeah, let this be this one. No scaling, scale by attribute, and let's call this break scale 2, which is our second attribute. This is where we use the second attribute noise we created. So now we can add this to Vellum solver, and we can start testing animation. So I did a few tests, and well, I ended up with very funny looking. This one was really good. So I like this one because it's a bit more looking like an hairball. So I did a little bit of tweaking on this one, disabled the gravity, and the rest length is set to 0.9, and basically yeah, the stiffness of bend and stretch have been increased a little bit. And in this one we have a little bit more stretch, and as you can see it will be pulling like that. So I did a few of these just to show you that after you build this procedural solver, you basically have a system now to tweak and get different results based on different parameters and different sim attributes and maybe different noise on those attributes. You might get different result. So now we can also check out the one that I ended up with. This is the one that I ended up with, and I think I like this one. I want to move forward with doing a very simple Redshift rendering setup to just show you how we can now render these. Yeah, so I have to first as you can see, rendering empty scene wouldn't show anything. First, we need to put some Redshift object tag. So we want these to be rendered as hair. So the setting for that is actually here. Render polygon as hair. And here we will set the thickness later. And for now, I will just create a Redshift dome light. And I'm gonna just use a light texture that I downloaded before. I usually get these from Polyhaven, so I think I got this Belfast sunset here, and now we can disable also the background in both viewport and render engine. And since we already enabled that, so now we should get something in here. Yeah, cool. But as you can see, the thickness is too much, so we'll go 10 times lower. Refresh. Yeah, much better. And let's make it even thinner. Even thinner. Yeah, I guess we're fine now. Let's see if we can get a... Oops, sorry. I have to be in my cam view. Lock it. Then see how would it look like up close. Yeah. Yeah. You can see their thicknesses up close as well. Okay, let's do a basic lighting and setup. With that, I'm gonna just start rotating my HDRI. Yeah, so not that much change. Maybe I can increase exposure a little bit and the intensity a little bit. Yeah, So this is quite flat. Let's maybe even decrease the lighting. Yeah. Now start adding additional light, like this far side, and yeah, now we can even look through the light. So if we check this light, this is an area light, and can put it to 5. And look this direction, lock this on. Yep, camera 1 is still on, changing the light. Basically we're piloting the light. So yeah, for example, this will be one light, and then we can always create a new one. And yeah, put it on the other side with a little bit of distance, and also reduce intensity. Let's bring the intensities down, they're quite high. This is 5. Let's put this 10. And even go a little bit further. And to other block. Make this a little bit small. Intensity on 10. Get it. Close. Yeah, maybe 50. And put it behind a little bit. Let's make it purplish. Let's make the other one bluish. Let's make other one a little bit more purplish. Yeah. And now what we want is a good material for the hair. So what we can do is go here and render, type matte hair, and then we go to matte, create a redshift material builder, RS material builder, and call that hair. And then go inside, we can even refresh this. This is already assigned. We might be able to add an RS hair, principled hair, or RS hair as well as possible. So let's try with both. As you can see, we have internal reflections. So this is working with many different type of algorithms, research done on subsurface scattering and hair shaders, and let's see what we can do, the best we can do with the parameters we have. So this is our internal reflection where we can put this to, let's say, bright pink, our diffuse is also pinkish white, and our transmission can be reddish or purplish, maybe. Let's go somewhere close to our previous color area, and primary reflection also white, and we can increase this reflection as well to maybe 0.8, so yeah, bit of shininess to, yeah, decrease the glossiness so it's less sharp. Increase it a little more. And yeah, for some weird reflections, we can also increase the IOR, but I'm gonna leave it at that. And you can have a little bit of transparency included in there. And yeah, that's it. Now we can start rendering this out. See you in a bit after the render is finished. Okay, now the render is ready and we can see the result. This was just a very basic lighting and shading and very low quality render. Just a demonstration of what you can do with Vellum and Vellum Hair and the glue constraints. I hope you guys enjoyed the tutorial, and if you enjoyed it, please like and subscribe. Thank you very much.